We're now going to talk about key methods in the Java RecursiveAction and RecursiveTask subclasses. And there's just a handful of them, so this won't take too long, but they're really important to understand because your assignment expects you to know how to use them. So we're going to talk about RecursiveAction and RecursiveTask, which are subclasses of ForkJoinTask. They extend ForkJoinTask. So RecursiveAction extends ForkJoinTask, but does not return a result. So if you look carefully at the RecursiveAction signatures for it in its UML diagram, you'll see that it has a compute and exec method, and compute returns nothing, returns void, which means it doesn't have a return value. And you'll also notice that this is not parameterized by anything. This is just going to have a compute hook method, and there's an exec method for reasons we'll talk about in a second. When you use RecursiveAction, you override its compute hook method that we just looked at to actually perform the computation that you want to have taking place in that instance of RecursiveAction. Now, typically the way this works, and this should come as no surprise, this is sort of the basic approach for all the ForkJoinTask stuff. If the data size for that particular instance of RecursiveAction falls below a certain threshold, then perform the work directly. So at that point, you just do it sequentially without having to do any other extra work. However, if the data size is larger than whatever the threshold is that you define, split the work up into smaller subtasks that are then forked to run in parallel. And the typical way that you do this is you take whatever you've got at that point in your RecursiveAction compute process, you chop it in half, hopefully evenly, hopefully efficiently, and then you take the right-hand side and you fork something to run the right-hand side. You update yourself on the left-hand side, and then you continue and compute on yourself. And we'll take a closer look at that idiom a little bit later. The smaller subtasks are joined in this model. However, there's no result returned from compute, because as you can see, compute is a void method. It returns nothing. So what will you do with the results? Well, common thing you'll do is you'll store them in an array or a list or some collection of some kind. And so we'll talk about that, look at some case studies to illustrate that later. Now, the way this works under the hood is there's an exec method that's provided as in part of the RecursiveAction. And the ForkJoin framework calls exec. And what exec does is it calls to the compute method, and that's the method you define. And exec is just a way of being able to call to compute, and then it just returns true. It says it worked, whatever worked means. Now, of course, it could throw an exception. This is an example of the good old template method pattern from the Gang of Four book. Hopefully you're familiar with the Gang of Four book from other classes. Hopefully you're familiar with the template method pattern. Template method pattern basically says, let's have an algorithm with a sequence of steps. It could be very simple, as it is in this case. And let's let some of those steps be overridable by subclasses. So we'll keep the steps the same, but what the steps do could be customized by a subclass. So if you look up here, you can see exec is the template method. Compute is the so-called hook method or the implementation method. And when exec gets called by the framework, it calls back to compute. You can customize what compute does. So that's the template method pattern. Proving once again that patterns are very useful for all kinds of things. And the result of compute is not stored for any subsequent access by design. It's not intended to. Let's talk about the RecursiveTask class, which does in fact return a result for a good reason. So as you can see here, if you look carefully, RecursiveTask, this is incorrect. It doesn't return void. I don't know why it says void, but it should return the type v from compute. I'll have to fix that. I'm not sure why it says that. So the subclass, just like with RecursiveAction, there's a compute method, with the difference being it returns a value v, and that will perform the main computation. Once again, if the data size is below a certain threshold, just do it directly and sequentially. Otherwise, split it up into 2 or more chunks and have those run in parallel. You're getting a feeling this is all very similar, which is by design. However, the difference here is the results of the smaller subtasks that the compute method forks will be joined back together again into a single merged result. at that level of the hierarchy of recursive calls to recursive task, which is why it's a recursive task. Once again, there's an exec method, which is going to be called by the framework. The difference, of course, is that in this case, compute is called, and that will go ahead and stash the result here, which gets stored up here, and this will be passed back in a different way. So that's the way in which the recursive action and recursive subtasks are structured. Of course, for the assignment that you're doing, is you will go ahead and make instances of ForkJoinTask for things like URL crawler task or process image task or perform transform task or whatever. And you'll fill in the compute methods to do what you need to do at that point in the processing and the recursion.